make it. Welcome to our March pit stop. I'm really excited today because my partner in crime, Janet Peters, agreed to help me with this particular pit stop. For those of you who don't know Janet, she's the Assistant Vice Chancellor. Um, oh gosh, Assistant Vice Chancellor of Academic
Academic engagement.
Affairs.
Engagement.
Academic. Every campus has slightly different, but she's
Hmm.
also a professor of psychology. And so she's the real brains behind this operation. I just get to play along at home with all of you all. So we've got some stuff planned for you. I think we're okay with questions in the middle. Is that okay with you, Janet? And we're really hoping that today we can give you some concrete ideas for how to create more effective PowerPoints that would go with your presentations or lectures. So this is not just for folks who are in the classroom, but really for any of you that are having to put together a PowerPoint deck. And what we think is really sort of special about this particular pit stop is that we're drawing on literature from cognitive psychology and a little bit of neuroscience um, that tells us a little bit about how people process information and learn. So I'm going to let Janet get started.
Okay. You just screen share here. First of all, of course, and as always, hi, hearty welcome. So good to see you all and spend some time with you. So Eric and I are talking about this idea that how do you do PowerPoints, but in ways that are effective for learning for your students. So what I want to do is I want to show you something and I want to see if you can figure it out. I'm going to show you some pennies and I don't want you to cheat. So if you have a penny in your pocket or on your desk, don't look at it. And I'm going to show you a bunch of pennies and see if you can, if you know what a real penny look like. What does a penny look like? All right. So here you go. Which is the real penny? Please feel free to drop that in the chat. Which one do you think is the real penny? I'm not going to give you like too much time, but I'm curious which one you think is the real penny. I see some N, I see a J, I, A, D, I. We'll give 10 more seconds to see if you can guess. JJ, Kelly's jumping on the I bandwagon, as is Amy. Okay, lots of I's. So let me go ahead and show you which one is the real penny. We'll reveal the answer here, and it's A, which I do think one person said. Um, and so the reason I like to do this exercise, I do this with students sometimes, and with the purpose being that like we have an idea of what that we know what a penny is because we understand the basic characteristics of a penny. It's the brown one, right? Like if you're comparing, and that model works if all you're doing is comparing a penny to a nickel or a dime. But the level of information that we want our students to learn is usually deeper than those like superficial characteristics, right? Like we want them to be able to dive in and understand details. The problem is that we get persuaded by these superficial things that exist without understanding the depth. And so the question that Erica and I really want to get to is how do we create the presentations that support student learning? How do we create presentations that help students pick the right penny? Now, of course, that's a metaphor. But the amount of detail you had to know about a penny, where what site is the year located on? Who's on the penny? What else is written on there? How do we create presentations that support that like level of knowledge that we're seeking and not just sort of superficial characteristics? Um, and the good news is there's a whole sort of science behind that. So that's what we're trying to tap into today.
All right, so our big agenda for today, thanks, Janet, for getting us started on that. First, we're going to do a quick overview of some of the science that Janet's alluding to. And I mean quick overview. So there's going to be some of you who are familiar with this. And you're going to think, oh my gosh, Erika, that's far too simple. But we just want to give you a flavor of what we're tapping into in terms of the theories of learning and what we know from cognitive science that'll help us make good design decisions. And then we're going to talk about how that theory actually leads to a set of principles that you can put into play. So we're thinking about part two as being the concrete, actionable examples that might light your fire about what you can do to create more effective presentations for your classroom. Go ahead and advance to the next slide.
Yeah.
Yeah. So I'd like to share with you, okay, a little bit about my journey. So this question about um, how do we create something that is better for student learning? I mean, I think about my first time stepping into a classroom as a professor. I was lucky in that as a graduate student, I had been able to take some pedagogy courses. So I walked into that environment with a little bit more confidence, I think, perhaps than folks who didn't have any formal teaching experience or teacher training before coming in. But I was certainly pretty far from being an effective teacher at that point. And really, what was not effective was that um, during the times when I was lecturing to students, I really wasn't tapping into what we know about how their brains work or how they process information, or really what we know about how people learn. And so that's where this cognitive theory of multimedia learning comes into play. So go ahead and do next slide for me, Janet. And so I think about just maybe what I was doing. I wasn't talking about plants, but this is an example of, what commonly we do when we walk into a classroom and we're kicking off a day with a mini lecture, or we're wrapping up the day with a mini lecture. And so I just, people are texting me and it's very distracting. Um, when we think about the learning piece, I'm conveying information to my students. I'm conveying information to you right now. And my hope is that as part of that learning process, I am going to encode information that you will store in your long-term memory. So go ahead and click. Right. So that's kind of my goal, right? I want you to acquire some information that you can draw on later, either for problem solving or to draw on later when you're answering questions. And in order to do that, I need to understand how it is that that information gets encoded into long-term memory. And it turns out all of the work that happens in encoding stuff for long-term memory happens in this space called working memory. And I've represented it here as like this giant whiteboard, because this is where all the work is going to happen on this dry erase board. And so as I'm talking to my students and giving them information, they're collecting that information in working memory in one of two forms. Like right now, I'm talking, and so that is entering into working memory in the form of sound that they can, and it's coming in on its own channel, right? Is what this theory would tell us. And then also any images that are in front of them, that information is coming in through the eyes and entering into working memory. Now, what our brain does is it's going to do a little bit of work, and it's going to be connecting this information that's coming in. The sounds we're going to put together and generate sort of a verbal model. We're reorganizing what we're listening to, and we're making connections. And similarly, with the imagery that's coming in, our brain is organizing that. It's making connections. And if I'm successful at helping those connections being made, I'm actually going to be making connections with information that I retrieved from long-term memory. And so then all that information will go back and get encoded in long-term memory. That's a whole lot of edu speak. Let's get on to the fun stuff. What I really want you to take away from this is that this theory of multimedia learning is really driven by three core assumptions. One is that information can enter into working memory through two channels, and I'll talk more about that in a second. The other assumption is that we have limited capacity in working memory, okay? So we have a bucket, and if we put too much information, it's going to spill over and go all over the floor, and we are not going to be able to do anything effective with it. And then the third assumption is that When we are learning, it's an active process. Okay. So just, I cannot open up your head and pour the information in and have it trickle into long-term memory. There's an active piece that needs to happen there. And so for today, uh, Janet and I are really focusing on those first two assumptions because those are the pieces that we can control and think about when we're designing our PowerPoint presentations. So let me tell you just a little bit more detail about those. Okay. In the first assumption that I talked to you about, it was that our brains process information through two separate channels. One of those channels processes visual information. So that's images, icons, things that we can see, right? The other thing, and this can actually include written words, okay? So that's what's interesting. The other channel processes verbal information. So that's the things that we can hear. Actually, I screwed that up, didn't I, Janet? Yeah, I did. Um, you process words. Sorry, you process words and words come in through sound. So words can be narration, they can be written words on the screen, but those are the two channels that we're processing information through. And then each of those has a certain amount that you can have in working memory anytime. So the example I give is for this is why do you think that our phone numbers tend to only be 7 numbers? And the answer is that our capacity for working memory is really 4 to 7 items. And so if we want to link them together and hold them together, the end product is we have the perfect number for memorizing phone numbers, if you will. Okay. So the two big picture items here are that we have two channels that we process information through, visuals and words, and there's limited capacity. So we can't just absorb everything all at once. So from these two assumptions, Janet's going to share with you some of the principles that we can apply. But the big take-home message I want you to get from the last slide is that we should be using in our presentations both text and imagery. And we should be keeping those things simple and on point because we have limited capacity for the number of things that we can hold in working memory at any one time.
Okay, so I get to do the fun part. Erika did all the theoretical groundwork. I get to do the fun part. And again, as a reminder, what you see on the screen, this idea of using text and images, we have this opportunity for two channels, and we want to maximize or leverage both of them. We don't want them to compete, and we don't want to miss out on opportunity from either one. So the next one that I'm going to show you, this is from a conference talk that I give where I was talking about a thing that we do on our campus called Equity Academy, and I was talking about some of the different interventions that we use on our campus. And so here's how I presented these categories of interventions. So here you can see the first one was learning assistants, which are teaching assistants. There's a pretty simple image that puts someone as a teacher, and then the word that goes along with it. And then I presented other types of teaching interventions, things that would support attendance and engagement. The approaches you use in class that scaffold student learning. And so looking at it from a more academic standpoint. You've got grading policies, right? And how do you have authentic assessment? And then there's other like socio-emotional types of interventions. And so what that dual processing theory talks about is that like these types of slides help engage us, right? When you have a picture that reflects the content, that is another way for us to meaningfully process the content. But you're going to see what we're going to talk about next is there's some rules around this. It's not just sort of, hey, May, you want to be intentional about how you pick these things. This is a slide from my research methods class where we talked about different surveys. And so instead of just listing them, you can see I have the words and then a little icon or image that represents it. And in this case, I've also used color. So I don't know if any researchers there, but particularly behavioral science researchers can probably guess why I make the internet survey icon orange. And that's because that is a way to signal to students like, okay, there's something different about this one. So you're using that imagery available to you to reiterate the point that you're going to make, which in my case is we rely heavily on internet surveys. For a variety of reasons that we would delve into the class. But this is the idea. You've got icons, you've got text, and you are, which we'll talk about in a little bit, like you are signaling. So that's some example. And so I'll let Erika do sort of the takeaways before I tell you like what the exact principles are.
Okay, big key takeaways. From the dual processing assumption, we know that we should be striving in our presentations to couple imagery and text together because that essentially doubles the amount of information that can go into working memory and helps people make connections between ideas. And the more connections we make, the more likely we are to remember and learn it. But the caveat to that is that we want to keep the imagery and the text very simple, so that we're not overloading our working memory. And then, ideally, if we want that learning to last, they need opportunities to practice. So there's going to be more time during your lecture where you're going to have them interacting and working with the material to increase the connectivity. Now, the piece around this that I want to kind of point out is that Janet and I aren't talking at all about aesthetics of the slides, right? So I am I'm a biochemist. I don't have a really good eye for color or fashion or style. So although I can create PowerPoint slides that adhere to these ideas, that doesn't necessarily mean they're the prettiest slides. But that's okay for me because I really want to make sure that I'm presenting the information in a way that I know will help my students process information efficiently and ultimately be able to store it into long-term memory. So I don't want you to think that we're just asking you to go and put a bunch of pictures on slides, but I want you to think about it with this sort of intentionality and also give yourself grace if the first times you do it, it's not as aesthetically nice as Janet's are because she's been doing this for a lot longer than many of us.
Yeah, I want to piggyback off that and just reiterate that point of like aesthetic. You could go and play with color or play with other things that might make it look really polished, but a polished slide deck is not necessarily an informative or effective one. Those are different things. So I get to do the principles with you, or at least some of them. So these are the four principles. There's more. Meyer, the researcher associated with CTML, he's got lots of different theories. We're going to talk about a few that I think are easy ones to sort of check off right away to look at your slides and be like, do I do these things? And where and how do I need to improve them? So the first one is called spatial contiguity. And I'm going to show you a picture. And I want you to look at it and tell me how many groups of things do you see? How many groups are there? And most people, yeah, I see it on the, there's two. But like, there's really nothing about those that suggests that they're groups other than the fact that they are close to each other, right? It is their physical proximity to each other that in our brain, we recognize that as a pattern, which in this case, we interpret as a group. So I'm going to show you one more image. And I want you to look at that image. And once again, how many groups do you see? Sees four, four. Okay. let's see. I think a lot of it's interesting to hear four. Oh, I see four because there's four total. I should have hid the first one. But look at those last two groups, right? They have different shapes in them, but the proximity is such a strong factor that we override even differences in shape. So most people say that they see, like in this case, these four groups, but particularly those two last groups, they see those as a group of 9 and a group of 6. They don't see a group of triangles and a group of circles, right? And the reason that they don't see it is because they are separated by space. They are chunked and grouped together. And so all of that is to say is this entire theory is about helping your students put things in groups that makes it easier for our brain to process, because our brain loves to put things in groups. And when you put things close to each other, our brain automatically does that work. So I'm going to give you so here's the principle. Put words near the graphic. And so here you see two different ways to show parts of a brain. One, all of the labels are separated, right? You think about like space, they're separated from the brain. And the image on the right, they are in location relative to where they are in the brain. What research shows is the one on the right is easier for people to process and remember than the one on the left, because the one on the left requires extra steps. It requires you to look at A, go down to the key, find frontal lobe, and go put it back. And then you have to do that for everyone in the process. So you can see here that like putting things close to where they belong is what you want to do. I'm going to give you another example. This one is from my class that I had when I taught intro. The first one is a bad example, and then the second one is from when I went back and fixed it. So here, I teach intro to psych sometimes, and we talk about the sympathetic versus the parasympathetic nervous system. And if you're not sure, one of these systems is associated with like arousal and getting your heart rate going, right? And your fight or flight response. And one of them is associated with like calming, rest, and digest. And if you look at my slides, purely my slides, you probably can't tell which is which unless you already know. But this is after I fixed it, right? So you see the cat that's like, that's our sympathetic nervous system. That's our fight or flight response kicking in. So, and then the parasympathetic is rest and digest. And so that kind of visualization, all the content on the slides is the same, but you see I rearranged them so that instead of the pictures just being kind of out in space, they are chunked. They're using that spatial contiguity to put them close to each other. And the slide on the right is much more easier to even understand at a glance. So if you're using pictures, don't just put them on there, put them next to the concepts that they have. Now, I say my definitions out loud and have students write them down, and I give them time. But if you're someone that puts definitions on the slide, put the definition under sympathetic and the parasympathetic under there, so that, again, you have them visually separated and chunked for your students, as opposed to something, again, on the left. Okay, so a few other examples of how I use chunking. I also teach stats, and we talk about like sneaky data. And so I have concepts here, and I have them chunked so that students can sort of see, okay, all of these concepts, along with measures of central tendency, graphing issues, research methods, and then other conceptual issues. And so by creating those distinct chunks, that's what this theory is all about. Instead of throwing everything up in ways that our brain just kind of jumbles, is taking those chunks. Okay, so the other principle, this is the one that I have a hard time with, is principle 2, coherence, which is basically you got to get it together, you got to delete extraneous material. Like you want to think about and be really intentional about what you are putting on your slides, whether it could be for a research audience, could be for your students, but you want to pick the most important things because remember that working load that Erika was talking about? Humans are not designed to drink from a fire hose, right? And so we want our slides to reflect that. So again, here's a slide that has a lot of content on it. You would have to read this very closely. It would probably be pretty difficult to write this down. But if we look at a slightly improved slide, this slide is from a project I did where part of the goal was to help faculty think about highlighting diverse researchers in their field and how to create inclusive content. And so one of the studies in this computer science class was from this researcher, Cherian, who she found that like your environment matters. And so as part of that environment matters, she partnered with Mattel and built and created a bunch of different Barbies and scientific Barbies and a computer science Barbie to help support, that was based off of this research that she did. You can see there's a lot less to process content-wise than there is here, and I would tell the story of the research that she conducted. Other examples, and I think this one is is Erika's.
Yeah, like when I thought about how to present limited capacity assumption, um, the example on the left adheres to the first kind of principle that we gave you, which was do use text and do use imagery. But if I were to use this, what it's doing here is that it's got 4 different images, and your brain isn't really sure which one it needs to pay attention to, right? Like the eye, maybe I used that one intentionally because I wanted to tell you that you have limited capacity for information. Maybe I was using the brain because I wanted you to think about the working memory piece. So I put that imagery there. And then, I have a picture of a classroom because that's where the learning is happening. And so if I'm giving a lecture on this, you're not only reading what I've put there, but your brain is trying to make a connection between what was written and what those pictures are. And it's kind of like hearing a record, like, a scratch across a record. Like there's just some dissonance there. And so what I ended up going for was this second example that I showed you previously, which is a stronger representation. Whoops. So, I still have the imagery, but I only chose one image. I chose an image very strategically. And then I did use some language around that image when I introduced it to you to say, like, our working memory is like a bucket. It can only hold so much water. And so knowledge coming in, if we fill the bucket too full, it'll spill out and you won't be able to effectively use what's on the floor. Okay. So keep in mind, there's one piece about this with this principle. Remember, we have the 2 channels that we process information through, visuals and words. It turns out that if I read my text that's on the screen and it is the exact same as what I've written, I am clogging up your working memory because narration and visual words get processed through that word channel together. And so it's just better to have me talking and narrating with an image than it is for me to have my exact words on the screen and have you listen to me talk about them. Okay, your turn, Janet.
Yeah. I would say, you brought up the reading the words on the screen. And I get the privilege, I get to sit in a lot of faculty's classes, which is cool. And I go to a bunch of research talks at conferences and like the reading the words on the screen kills my soul just a little bit. Oh, I don't know how many of you do that. I don't know, but I will say that kills my soul a little bit. Partly from an engagement perspective, and then also there is the science behind it that shows like that is literally less effective. And so you're missing out on this opportunity to add in nuance and meaning to your slides and to your content by just repeating what's already there. Okay, so let's go to the next principle, principle 3, which is signaling. So our brains are pretty adept at scanning things, and we like it when our attention is called out to something. And so as part of this theory, one of the things that they talk about is signaling where something is important or highlighting this essential material. So here you can see this is from my stats class, and we calculate standard error. And I am trying to tell them, hey, when you, like, we always use the population standard deviation. We would, in this specific thing, we would never use the sample standard deviation. So I have that not in a list, but as an arrow that points to that part of the equation to be like, hey, this is really, really important. Other ways that you can do it are through like sort of highlighting or underlining. But the point is you are helping them zone in on it. What I will say is this is a cautionary tale a little bit of like, if you highlight everything, it no longer holds meaning. So if you're looking at your slide and on every slide you have something highlighted or underlined, it is something you want to use strategically and sparingly, because the whole idea is that it is novel to call your attention. And if you have it everywhere at once, it's not going to be as effective as you would want it to be. But if there is something that is like absolutely critical, a consideration, a piece of nuance, part of a definition, those are the things that you really want to like take that novelty and use it to your advantage. But again, if you highlight everything, then that doesn't quite work. So that's the nuance for the signaling principle. Okay. The next principle is modality. And I'm going to show it to you. And when you see the screen, there's going to be directions on the screen, and we'll talk about it. Okay. So the next one, it's predicated on you looking at the screen and seeing what is on the screen and following the directions. Okay. Here we go. So keep your eyes on that cross. And as you do, you will notice the faces start to become distorted. Okay, so it went once through. I'll let it run again. I'm curious, did it work? Could you see the distortion? Did the illusion work for you? Yeah? Okay. So this is an illusion that I show in my intro class to help them understand. We talk about sensation and perception and the concepts associated with this. I know, Kate, I like the because it's so weird. Is that doing something like this to present the content in a way that is dynamic, that we can use some of these deeper visuals rather than just text or rather than just static images that can show us what a principle is. And so when and where possible, I think you could think about like, are there GIFs that show concepts in your class in ways that your images don't? I've seen a lot of cool GIFs in physics. I've seen a lot of cool GIFs in stats, those kinds of things. I'll share one more that is in my class. Is we have this concept called inattentional blindness. And it's basically when we pay so much attention to one factor, we miss something that's, even if it's obvious to us. And the example you see on the left, there is a gorilla in the middle of that picture. And it's this classic experiment where, because of what the researchers do, basically all the participants don't see the gorilla. Even though it's clearly there, they don't see it. And I can explain that to you, but also it's probably not as effective as showing the video. So I will show them a video. The next one I'm going to show is a video, or it's a GIF of change blindness. And this is where, again, we focus on one thing that even if something changes, we get distracted for 1 minute, we don't notice a change. And so I'll show you the GIF. It's this, she drops her phone and you can see the guys switch out into a different person and she doesn't notice. Right. And so we talk a lot in my class about change blindness. Now, I'm, of course, not going as in depth as I would in my class, but here's a way to, instead of describing the process, a nice, quick little way to show them one example of how that might work. And so you might have those in your fields. Okay. So here's the last thing I'm going to do before I hand it back over to Erika is sort of show you like, what might it look like if we've got sort of multiple principles happening at the same time? And you don't have to do all of them. You'll see I don't have all the principles in my next slide, but this one is for my stats class. And like right now, we're learning about confidence intervals. And if you know about stats, you know that there's a lot of things that influence confidence intervals. And so I go through that with them. The first one that we talk about, you see, is variability. And so what you see here is you can see I've got an image that shows that has a normal distribution to it and talking about the spread of data, which is what variability is. You can see I have some information on the slides. We talk about it. Okay, we've done talking about it. And then we talk about sample size. And so how does sample size? What happens if you have a big sample? What happens if you have a small sample? How does that change like a big versus a more narrow confidence interval? And then we talk about how confident we are, right? So what you see here is you see the spatial, everything is chunked and grouped in ways that make it really clear from A to B to C. The other thing is you notice I didn't just put all this information up right now. So if you look at this slide as is, like that's a good amount of info to process. But one of the things that I think I would want faculty to consider is even if you don't change how much you put on a single slide, although I do think you should think about that, right? The coherence principle. I think at minimum, trying to reduce cognitive load by only showing it one at a time, talk about it, and then do it. Because if you're like me, if your students are like mine, when they see all of this at once, what do they do? They write everything that is on the screen. And if they're writing about our level of confidence, the thing in green on the right, while I'm talking about variability, that is going to be a mismatch of what they are processing versus what I'm trying to talk to them about. So even using time as a chunking, I think would go a long ways. And then here, so we talk about all of this, A, B, and C, and then I also add this signaling. You can see it goes across the bottom. And this says, look, it doesn't matter which one you're talking about. Your sample quality matters. It matters where we get our data from and who collected it, who's in the sample, and where it came from. So that little bit of signaling there along the bottom. This is an example. This is from my stats class. We talked about this 2 days ago. And so it's using a lot of those principles, the spatial principles, the coherence principle. You can see I don't have anything dynamic in there. So it's not like you have to use all the principles all the time, but those are some ways to think about that.
And before you go on, Janet, or maybe, well, yeah. The other piece I want to add on here is by talking about these in discrete chunks, what that allows your brain to do in working memory is like if Janet was just talking about the variability stuff, and that was the only thing on the slide at the time, then all of the ideas that she's talking about related to variability are in working memory at the same time. And remember that as that information comes in, our brain automatically starts reorganizing it and creating schema. And there'll be either verbal schema or visual schema, but then your brain then tries to kind of get them connected so that they can be stored in long-term memory together. So by providing time for working memory to make some of those initial schema, that is actually um, useful because then when she starts talking about sample size, some of that variability stuff will still be rattling around in working memory. But now she's talking about sample size. And so some meaningful connections that relate that are important for us to remember about, sample size and variability and what that allows us to do in broader ideas about statistics, they're more likely to stick together, right? So she's really being strategic here about parsing what goes into working memory and thinking about what do I want ultimately to be connected so that it can be stored, learned into long-term memory.
Mhm.
So we've given you like Janet's really magical at giving concrete examples of how these ideas from research can be put into play with our um, when we're creating our own slide decks. Um, but we didn't give you an opportunity to do what's really important, and that is to actively put these ideas together. So I'm sad that we didn't have that time. But if you walk away from this pit stop with just two things that you're remembering, I think you'll be able to, um, on the fly, reenact these principles without remembering that the name was coherence or spatial contiguity, or I mean, right? If you can remember that we process information through two channels, through visuals and through words, words being text or narration, visuals being the graphics and imagery that we see. If you can remember that and think about it as each of those has its own capacity, right? They each have buckets. So if you're only presenting information through one channel, you only have this much that you can get your students to think about. If you utilize two buckets, that's more information. And it's allowing them to make those connections tightly between pieces of information in a way that it's more likely to be stored together and retrieved together from long-term memory. So you don't need to remember all those fancy names, but you do just need to think about this. Janet, do you have anything else you want to add?
Just reiterate sort of what you said, Erica, about like if I had a magic wand to support teaching, it would be chunking the information and yeah, both spatially and temporally of not putting so much on the slides that your audience is reading and trying to pull in so much visually while also trying to listen. I think that just our brains aren't don't detect patterns that well for that much information. We're much better at making those connections that Erika mentioned with less information and then building on it. So we have the capacity for that level of information, just not at one time. So like my biggest like thing I would want to say is just present the information, but just think about chunking it and building on it instead of putting it all out there. Cliff, I see you have a hand. I see one in the chat, so I'll stop sharing because we got questions.
Yeah,
Go ahead,
yeah.
Cliff.
Yeah, did you want to address Jesse's question first, in more detail?
Yeah, I can answer that super quick. The short
Go for
answer
it.
is yes, that's amazing. That would facilitate what we would call retrieval process, which is where someone learns something and you go back and visit it and you build on it. And that process of revisiting is like wonderful for learning. If you go to the cognitive research, I mean, that's one of the main study methods they suggest is retrieval, retrieval, retrieval. So callbacks, absolutely delightful. We love it. We love a good callback.
And because another piece of that is that part of learning is forgetting. So when we go to bed at night, we erase a bunch of stuff. And that's good. Like I don't want to remember everything from my day. But if you call back to something, it forces, like Janet said, it forces us to retrieve and use. And if we're retrieving, we're strengthening that neuronal connection. If we're using, we're allowing it to connect to other things. So back it can go. So having time between things is also really useful. But then Cliff had a question, right?
I do. So my suspicion is that some of us may tend to put lots of text on slides because we, rightly or wrongly, may be concerned that if we don't put it up there and we just say it, students won't capture it either in their notes or in their brains. And so that might drive some of our inclination to do that. So if we break ourselves of that habit, how then do we coach our students on capturing information that we're delivering mostly orally rather than on a presentation, whether visually or with text? Maybe that's a
Well,
different pit stop.
no, I'm into it. You're asking the tough questions. I will tell you what I do, not because I think it's like the best answer in the world, but I will tell you what I do because I think I showed you that one slide where it said parasympathetic and sympathetic, and it did not have the definitions of those. And that is a lot of how I do my slides. So I will tell you how I train my students. And the first is with silence in a nice way. So I will say, I will put up parasympathetic. And this is, I think, the hard thing for us. And then I stop talking because I give them 3 seconds to write that word down. And then once they've got it down, I'm like, what is this? And then I say the definition. And then I stop talking, right? So I stop talking so that they can write down the definition. And then I usually say it one more time just to make sure they can like reread their notes and do it. And then I jump in and I throw that picture of the cat up and I'm like, look, this is the thing that is fight or flight. This is the thing. And then I do elaboration that they can add while I talk about the example. But like for things like definitions, I give them verbally and I will be slow for like, this is what the parasympathetic is. And I found it's not any slower necessarily than just waiting for them to write stuff down from the board. And it forces, the reason I do it is because it forces engagement. It takes them a little bit to get used to it. I'm not saying everyone loves it all the time, but that's to me like that's one of the ways that I do it. And I have, depending on the class and the amount of content, but it seems to work okay. So silence and repeating is what I do.
And an opportunity to use it, right? So I could imagine there are times when let's say I'm teaching them what a hydrogen bond is. And like Janet said, I'm going to give them time to record whatever information they think is pertinent, but then I'm going to follow it up with some sort of question or activity that they immediately have to use that information because it's in working memory. And if they're using it, it's going to get connected. I think sometimes, Cliff, also like my guilty thing is I'll put the words on the slide because I'm scared. I'm scared I'll forget to tell the students that. Right. And I'm like, you know what, Erica, if I'm really that scared about it, I should just put it in the notes part and give them my lecture slides with all the notes. And that way, if I forget to say it, it's there. But that's my guilty thing that I do.
I have a related question. I think this is really interesting. I'm thinking about when we're sort of coaching graduate students to give their first scientific presentations. And a little guideline that I've used, and has no science behind it, but I'm learning that there may be some science behind it, is that your audience, or at least I think your audience has listeners, um, figure lookers, people who pay attention to figures, and readers. And your audience members, they don't exclusively use those, but they use parts and pieces of all of those. So you got to give them that. So I guess my question is more about this idea that narration and text, I think I understood you to say that it's processed in the same channel. So if you read the text that's on the slide, you actually clog up the system. I want to understand that a little bit better so that when I say, okay, you've got the readers and the listeners and the viewers, actually what I mean is you need those three things so that you can access both channels.
Yeah, I think I'm not sure I know how to answer the question, but it is, you're right, that if I am talking and you are reading,
Yeah.
your brain really can only attend to one of those,
Okay.
either the reading or the listening. And we like to convince ourselves that we can do both.
Right.
But really what we're doing is we're going between the words we're reading and what we're hearing. And it clogs us up. Our brain has difficulty trying to maintain focus on one or the other because it's the same channel.
Yeah.
Whereas I can still be seeing something and it's coming in and they're not competitive with one another,
Yeah.
if that makes sense.
I wonder if it's the few words that sort of signal this is what's going on in the image are kind of a bridge between the two channels, the visual and the verbal.
Hmm.
I also think it depends like what kind of image you're talking about,
Yeah,
right? Like the image of the cat being like, wow, that as an image is very different than like a graph of
Sure.
like a research output where the level of processing of that information is wholesale different than just seeing this like lazy cat on the couch. You know what I
Yeah,
mean? I think
fair.
yeah.
I think it probably depends on the image. The other thing I would say is, and I think this is true of all presentations, whether it's your graduate students presenting their first research or whether it's us in the classroom, is communicating our knowledge. If you are communicating it via written in a paper, in a textbook, that is where you're detailed and it's so thorough. And like, that's why we have our students read textbooks. And if you are trying to mimic that level of information in a presentation, I would argue that you are doing a losing battle,
Yeah,
right?
yeah,
Like if they want the full details, that's what the textbook's for.
sure.
That's what your published dissertation or your published paper is for. And I think when we go to talks or lectures where someone tries to put in that level of detail and they just run through and they're like, and then there's this and A B C D E F G H I J K L M N O P, it to me that's not effective communication. To me, what our lectures are and what our research talks and really any talk we're giving, we are taking a complex detailed topic and simplifying it.
Mhm.
And I think giving ourselves permission to not try to recreate the textbook, I think is one of the biggest things that we can do. And I think it's what makes these I'm doing this because you can't see my screen over here, but like that's how we enact the principles is
Yeah.
we figure out the way to pick out the important things, highlight those, make sure they have the building blocks, and then we can add on nuance. But I just think that like trying to they're different purposes.
Yeah, and
Every textbook is a different purpose.
I
And
think
so
you've just created another pit stop.
yeah, like just to me, my purpose when I teach intro is like there's so much in the textbook. I cannot regurgitate those
Right,
chapters to students,
right,
not
right.
without
Yeah.
throwing up a stupid amount of text on the slides, not without like ripping. And this the other thing is we need time to process stuff.
Mhm.
So if I have topics A through F, I'm going to cover and I just rip through them without practice. I can say I covered them, but I didn't cover them meaningfully.
Mhm.
Yeah.
So why not pick three, highlight those, and give them the time the process that they need to process the meaning? Like, so anywho, that's my TED talk on content. Sorry.
I mean, and the same thing, like Kate, when I think about the first research presentations I gave, or even my first lectures that I gave, I felt like I had to include everything
Right.
from and I think it came from the same fear, I guess, for lack of a better word, but like when you're in the classroom, you think you have to be the expert in order to be respected by your students, right?
Mhm.
And when you're giving a research talk, you need to be the expert because you don't want somebody to think that you're, not doing good research. But at the same time, we get so into the details that actually, unless somebody, like when I'm thinking about a research talk, unless somebody is in my exact subdiscipline, I've actually I've bored them to death, right?
Sure,
And I
sure.
would much rather have like, a few data slides that are chunked the right way, that I walk them through what everything means. I mean, the same principle that Janet had with variability and sample size, right? We can do our research talks like that too, where here's panel one,
Yeah,
here's panel two, rather than all of them up there at once.
yeah,
And it's really liberating, I think. And those, a good research presenter when you can follow along, even if it's not in your discipline, and you have a question, right? And
yeah,
so I try and
yeah.
tell my students, like, oh my gosh, you don't have to go into that much detail. Please don't.
Please don't.
I'm
Yeah.
bored. But yeah, I think some of it is just our imposter syndrome won't allow us
Yeah.
to keep it simple because we're worried people will think we don't know our stuff.
I think that's a really valuable lesson. Yeah, I'd encourage you guys to give a pit stop for folks who are thinking about effective research talks without vomiting all the details onto the slide.
Students can be a really good practice audience for that because they're not
Sure.
experts.
Yep,
Yeah.
yep.
And
And
their faces
yeah,
don't lie. When they're bored, they're bored.
yeah.
Yeah.
Uh-huh, no doubt. Well,
Well,
thank you all very much.
Thanks for
yeah,
coming.
thanks for being here. If anyone has any questions, other questions, or wants to chat, feel free to stick around.
And if
But
you loved it, you can
time,
tell
it
your
was so
friends.
nice.
It'll be posted in a few days on our YouTube channel so they can watch it too.
So nice to see you all. I will say, as you log off too, one thing I was going to say, a tiny tip. If you need help organizing your slides, if you don't already use the like smart art help in PowerPoint, that can go a long way to help you to force to think about how to chunk stuff. And also it does some heavy lifting for you. So if you know what I'm talking about, if you don't, you can stick around and I'll tell you. But tiny advice. Let Microsoft help you.